So one of the common topics that we discuss with our customers is EVB layout and development for our PAs. One of the most important things to consider is the thermal vias under the ground of our devices. It's important to have through vias all the way to ground in order to move that heat away from the device. Also to have a good amount of ground vias around the RF traces and around the components that are used for external matching. So yeah, just basically to have a good ground and a good layer stack up that's pretty close to what we use on our EVBs. So our board stack up information is available on our website under manufacturing packaging information tab for each part number. So all you have to do is go to search by our part number on our website, and that tab will be available to download our Gerber files. And if it's not there for some reason, feel free to reach out to us and we'll be happy to provide that information. So I've seen issues in customers' board layouts from not having 50 ohm RF lines to almost no ground vias, even no ground vias under the main ground die flag area that under our DUT. So those I'd say are the most common EVB layout issues I've seen.
Any of you guys call me Francis and I'll kill you.
The most common one, I've been given a few. One is that with small high gain PHEMT devices, they need a generous amount of VS ground underneath the device because PHEMT has a tendency to go unstable at 15 to 20 gigahertz. So too much inductance to ground underneath the device is bad. But I've also seen recently with a lot of customers on the top layer, their ground floods, they're not generous enough with their vias. They have a few vias here and there, and that's not a good idea. If they use coplanar waveguide, they should have machine gun vias along the RF traces. But in the other places in the flood, costs more to put vias, but you got to have enough for stability reasons. One mistake, I'm not sure I'm going to call it a mistake, but one thing I'm seeing customers do recently with their layouts is when you have a shunt capacitor to ground, a tuning capacitor, some customers use they go to the ground pad, and then from the ground pad they have thermals to vias. Those lines, they call them thermals. I don't know why, but they're just layout strips. Capacitor to ground through strips, 3 strips to vias, which adds inductance, and the capacitor is no longer, you're not getting the tuning result that you think. So I often send them a picture. Okay, see these strips to ground? Get rid of it. Flood the ground plane in where the strips are and put vias in there. So that could be part of your problem, that you're not getting the performance you want because this matching isn't what you think it is. So vias and just the way that they lay out for their capacitive terminations. The other thing is oftentimes on our boards with, say, a 5509, for example, we have from VCC2 to VCC1 on pin 13, we have a 0 ohm resistor. We have trace 0 ohm, and we put that 0 ohm resistor in there, and the reason we do it is, what they should conclude when they look at it is, okay, that's in case I condense my layout. And now you have a feedback issue, maybe, right? So I need isolation. I can put a ferrite in there. And there's been a few instances where a customer said, hey, man, the device is oscillating. And I say, okay, you didn't put that, you condensed your layout, you didn't put that resistor in, cut the trace and put a ferrite in and see if your oscillation goes away, and sometimes it does.
you develop a board and try it out apart and the performance isn't the same as what it was on our EVB, you could send it to us and we would come up with a tune for you if the board layout met the requirements with grounding and all that I mentioned before.
Thank you so much for watching. If you'd like more information, please email us at sales@gorilla-rf.com. And don't forget to subscribe to our channel for more content from Gorilla RF.